Okay, we're just going to continue with a few more examples for collisions. And collisions is not just two things coming together. It can be two things breaking apart as well. So we have a rifle. So I should have given more sig figs to these values. So 4.2, let's give those more sig figs. Same as this one, 2.000. Just so I can actually add this mass to it. Okay, so initially we have this gun. I don't know how to draw that gun, but it looks like a gun. And there's a bullet inside it. After we fire that gun, the bullet is outside. So the momentum before, let's equal the momentum later on. So initially, the rifle and the bullet are together. So we have a mass of 4.250 kilograms. But it has a speed of 0 meters per second. So our initial momentum is actually 0. So momentum of the bullet to the right, as a result, is going to have to equal the momentum of the gun to the left. So now the gun is going to recoil backwards. So 4.2 kilograms. We can calculate explicitly how much that recoil is. So the bullet is 0.050 kilograms, and it's traveling at 300 meters per second. So 0.05 times 300, move that to the other side of the equation, divide by 4.2, we get a speed of negative 3.6 meters per second. So this gun is going to recoil backwards at 3.6 meters per second. You just imagine, the bigger the caliber of the bullet, the more powerful the gun, the bigger the recoil. So if you're not prepared, if you ever go to a firing range and shoot a large gun, for example, get ready for that recoil. Like when holding a rifle, for example, you're told to brace the stock into the shoulder so that you can absorb some of that recoil. So now the bullets, in this next question, that bullet's move forward towards like some type of target. It's a block on the ground. And when it hits that block, it embeds itself. We're going to assume this block does not affix to the ground, so it's going to slide forward. So the question is, with what speed will this thing slide forward? So we have 0.050 kilograms times our 300 meters per second. And the momentum of this block, it's not moving initially, so it's 0 kilograms meters per second. And this is equal to our combined mass of 2.050 kilograms times some velocity. So pretty straightforward. We can solve for that velocity. 0.05 multiplied by 300 and divided by that 2.050. We get a speed of 7.3 meters per second. So this block will slide forward with an initial speed of 7.3. Of course, the sliding, it's going to experience friction, eventually slow to rest, but that's our initial speed. The next one is, what happens if instead the bullet pierced the block and the bullet was measured to have a speed of 180 after passing through? So for this one, again, we have that bullet, and we have a block. And afterwards, if you still have that block, there's now a hole in it probably. Well, it has to be in the bullet. So assuming the mass of the block is still the same, so initially we have that 0.050 kilogram bullet traveling at 300 meters per second. The momentum of this block initially is 0. Afterwards, that 2 kilogram block, it's going to be sliding forward at some speed, assuming it doesn't tip over. And the mass of the bullet is still 0.05. But now it's slowed down to 180 meters per second. So a little bit of algebra. 300 minus 180. You get 120 multiplied by 0.05 divided by 2. We see that the velocity of the block in this scenario is 3.0 meters per second. So the key idea for collision is just being able to picture what is going to happen before and what's going to happen afterwards. And we just need to solve for conservation of momentum, and we're good to go.